Good evening, everyone, and welcome to day 5 of Great Amrita Alumni Conclave on Driving the 21st Century, the Role of Chemical Engineers. Great Amrita Alumni Conclave is a full-fledged virtual webinar series spearheaded by the shining alumni of Amrita. These sessions are planned as a platform for every engineering aspirant to gather valuable information on all aspects of engineering and get to know the futuristic scope within the various streams of engineering. Today we have with us Mr. P.T.R. Gupta, Assistant Manager, Panipat Refinery, Indian Oil Corporation Limited, with us to join us for today's session. He has completed his chemical engineering in the year 2014 from Amrita School of Engineering. Now I would like to welcome him for the session.
Am I audible? Yeah, thank you, Nisa ma'am, for the intro. So it always feels great to be back at Amrita, although it's a virtual event. Hi everyone, good evening. My name is PTR Gupta, currently working as Assistant Manager at Indian Oil Corporation Limited. I did my BTech Chemical Engineering and passed out in the year 2014. Today I'll be presenting on the topic driving the 21st century and role of chemical engineers. So while I was at Amrita, I got placed at Chemplas Sanmar Limited as engineer trainee. It's a petrochemical company, and I worked there for 1 year, and then I moved to Indian Oil. So I'm currently working at Panipat Refinery of Indian Oil, and since 2015, I'm working here. I am also a certified boiler operation engineer by Government of Haryana, and I am also a certified auditor of ISO 50001 and 2018 energy management systems. My interests include process simulation and big data application in process industries like predictive analytics, hybrid modeling, etc. Okay. Okay. So I'll be walking through the following topics. First, we look at global challenges, current global challenges, how chemical engineers can be a part of the solution, and then the world energy outlook, current world energy outlook, and in that context, what are the emerging technologies, and specifically we look at refining and petrochemical scenario, and finally the role of chemical engineers and opportunities. So these are the few global challenges. So if you look at the main global challenge that we are facing is climate change. All of you might have heard about it in the form of melting glaciers and droughts and also floods, global warming in the rise of Earth's temperature, and also coming to the clean water. Most of the developing nations and developed countries still don't have access to clean and hygienic drinking water for most of their population. So it is still a challenge. And regarding the healthcare, all of you might have realized its importance during the pandemic, the vaccine discovery, and so on. So the production of vaccine and other social challenges like population control, mental health crisis, and peace and conflict like the geopolitical wars and all, and finally the poverty. The bridge between rich and poor is growing day by day. So the the solution to these problems is both technological and also in terms of the change in policies required by the governments. So these are just a few challenges. So we'll now look at how chemical engineers can be a part of the solution. We'll look at especially the climate change because that is where the whole energy landscape is going to change. So if you look at the sequence of climate change, so basically the greenhouse gases, the main gases are the carbon dioxide and methane. The emission of these greenhouse gases, the main sources are from the vehicular pollution and also the consumption by manufacturing sector and energy sector. So these form the bulk of the emissions, and apart from that, we have emissions from agriculture and other human related activities, but majority of the emissions are from manufacturing sector and industry, and also from energy sector. So basically these gases trap the heat in the atmosphere and then in turn cause the global warming, and global warming will lead to the all the extreme climatic events which we just talked about. And then the solution to this climate change is the sustainable development. Sustainable development is nothing but consuming the resources so that coming generations will not suffer by overconsumption. And also everyone knows we have finite resources, right? So in that context, sustainable development will be the solution to climate change. So for sustainable development, we need to replace the current technologies. Like you have the vehicles, vehicular pollution, the mobilities, everything is fuel based now. So to decrease the emission of these greenhouse gases from vehicles and other energy sector and manufacturing sector, we'll have to switch to renewable and low emission technologies, and then this will result in a green future. This is if you can and this is a trend of CO2 emissions, and also methane emissions are also included in it in terms of equivalent CO2 emissions. If you look at the trend since from starting from 2005 till 2020, the dip is due to the pandemic. Most of the people, due to the global lockdown, the emissions have decreased, and they continue to rise. This is a prediction by BP Statistical Review, and by 2035 they will reach around 90 gigatons. So if we continue to increase the CO2 emissions, at one point there will be an irreversible damage, and eventually the whole ecological system will collapse. So in this context, I will just explain uh, what are the sources of CO2 and how best we can manage the CO2 emissions and also capture the CO2 emissions. So in this schematic, you can see two sources for the CO2 emissions. One is the natural sink, and another is the human-made CO2 emissions. That is the emissions from uh, energy sector and manufacturing sector. And you have two outputs. One is the natural output, that is the carbon sinks, and another is the uh, engineered reservoirs. We'll talk about it more in the coming slides. So basically, if you want to limit the CO2 in the atmosphere, ultimately you will have to decrease the human made CO2 emissions, that is from the energy sector. So either we'll have to replace it with an alternative technology, or we'll have to create a new sink where whatever be the CO2 produced and released in the atmosphere, that has to be captured and stored and utilized. So the current technology is the storing of CO2 in the coral reefs. So basically they capture it and store it in the coral reefs. So in this context, so recently, Conference of Parties 26 was held in UK, and all global leaders have gathered and they have committed to the net zero emissions by 2050, so that the global warming is limited to 1.5 degrees Celsius. Currently, it is 1.1 degrees Celsius already, so we have only zero point 0.4 degrees Celsius margin to meet that commitment. And 75% of the emissions are contributed by energy sector. And the solution to this climate change would be shift to renewables and low emission intensive fuels, and also improving the energy efficiency, and adopting a concept called circular economy, like recycling and whatever be the, let us say you can take an example of plastics. Many of the plastics, they can be recycled so that the resources can be utilized in a effective manner. And finally, carbon storage and sequestration. The CO2 in the atmosphere is captured and stored and utilized for some other purpose, or there are few purposes like chemical production and also enhanced oil recovery and also sequestration. We can store it in the coral reefs. If you look at the world energy outlook, so you see that a majority of the share is occupied by oil and gas. So it's around 600 exajoules is the total current consumption. And if you look at the trend on the right side, you would see that the share of the natural gas and oil is declining, but and other renewables are increasing. But this share, this decrease in oil and gas, I mean the crude consumption, would not necessarily mean the total crude consumption is decreased, because there is a sector in oil and gas where petrochemical sector, where the a fraction of crude oil is converted into naphtha, and it is used for producing petrochemicals, and petrochemicals growth is growing exponentially. And so the crude oil, although it is decreased for the energy consumption, it would increase because of the petrochemical demand. So if you look at the changes in the total energy supply by 2015, this is how this is predicted by International Energy Agency. So it's a energy agency for predicting the changes related to climate change. If you look at the first horizontal bar, that is the current situation. So in that, if you see, oil and coal and oil is taking the major portion of energy supply. So there are these three scenarios. One is the STEPS, APS, and NZD. STEPS is nothing but stated economic policy scenario. Whatever the governments have taken the steps, because of that, the change in the energy supply. So that is shown in the second horizontal bar. And announced pledge scenario, I told you about COP26, where governments have mentioned about they have committed much more implementation of the low emission technologies. So if that is being followed, what would be the energy supply scenario? And finally, we have net zero emissions by 2050. If we completely stop the emissions, like whatever the emissions we are making, so that is either sequestrated, or we are not making emissions at all by adopting solar and wind power. So you can see the drastic increase in the renewable energy supply by 2050. So in this climate change context, the emerging technologies would be biofuels, blue and green hydrogen, and solar and wind. Solar and wind, they don't cause any emissions in the production of the energy. So, and also it should be coupled with the electric vehicles and other mobility, other renewable based mobility option like fuel cells, etc., and also hydrogen cells, etc. And finally, in clean energy context, we have carbon storage, carbon capture, utilization, and storage. And coming to in general, emerging technologies will be oil to chemicals. We'll come to that in few moments. And one more industry that is emerging is computer aided decision making coupled with big data. So all of you might have heard saying that data is the new oil. So it is foraying into the chemical sector. The With the advent of artificial intelligence, machine learning, and digital twins, they are helping these industries in improving the profitability. So this is one area where you would see a lot of growth. So this is the market size for clean energy tech. Just like the two scenarios that I have mentioned before, the 2020 scenario, you could see it's around $150 billion in 2020, and it would increase up to $1,200 billion. So it is almost sixfold. So this right now we are implementing few measures that is shown in APS, that is advanced pledge scenario. Because of that announced pledge scenario, because of that, we have 32 CO2 equivalent emissions, and with the net zero emissions, it is coming around 22. So the gap is filled by the cost effective technology measures, and within the cost effective technology measures, We have wind and solar taking the major share. So this is employment growth in clean energy. So if you look at coal and oil and gas, there would be decrease in the jobs, but the decrease in the jobs in oil and gas will be compensated by the petrochemical sector. Then in the automobile industry, you can see there will be net decrease in the jobs. You can see bioenergy and use renewables, critical minerals that are used for, that are consumed in the batteries and renewable production. You will see a net increase in the jobs. Coming to the biofuels, you have a variety of feedstocks like from agricultural residue, like the stubbles that is being burnt. One classic example is in and around Delhi NCR, there is a lot of stubble burning. So now companies, including my company Indian Oil, had adapted a 2G, 3G ethanol where the stubble is being collected and it is converted into ethanol. And ethanol is blended as a gasoline and diesel fuel, gasoline fuel. So there are various technologies, conversion technologies, and finally you will get hydrogen, methanol, bioil, biogas, and also ethanol and biodiesel. And the end use would be they are mapped to fuel cell vehicles, gasoline vehicles, and diesel vehicles. So coming to the application of big data in process industries. So hybrid modeling. So basically in chemical industries, what happens is all the processes that takes place are modeled using the first principles. What are whatever the concepts that are applicable to chemical engineering, they are being used and models are being generated. So what happens in the typical process industries, you have lot of data being generated. So in artificial intelligence, you have some models called neural network models, wherein they try to analyze the data, filter the data and analyze the data, and then they will find try to find the patterns within the data. So let us say if you have two refinery setups, so for one refinery setup, there only a specific model will be applicable, so that you cannot replicate in a different refinery, because the configuration and all is different. So the first principle based model and this data based model, the model in which patterns are being found and functions are being made. So these two are coupled together, and finally there is this advanced infused hybrid modeling. And coming to advanced process control, in typical industry, process control is using a normal functional block with which takes the disturbance variable and gives the output so that corrective action is taken. But in advanced process control, it will try to, based on the historical data of the operating conditions, and also the data of the lab quality parameters, it will predict a model, and based on that it will take action. So they basically it's an advanced control, so that the response time will be very less. And then fault diagnosis, if you have any upset in the events, or suddenly if your plant trips or if your process is disturbed, it will automatically analyze the data and it will tell you the solution and prescribe what is the solution, and also the root cause. Predictive analytics is nothing but the prediction of parameters of the end products based on the operating conditions. So it is somewhat similar to advanced process control. And supply chain management, it's called integrated planning modeling. So if you look at a typical refinery operations, you have lot of variables to take care of. You have lot of crude blends, like you have crude from Basra, you have crude from West Trade International, and you have crude from other Arab countries. So the 70% of the process of the cost of producing the fuel products goes to the cost of the crude oil. Only 30% is the processing cost. So you should be very wise in deciding what should be, which crude blend should be you should select, so that your profitability is maximized. So in that context, this supply chain management IP modeling tools are very important. Remote sensing and automation, if coming to the context of Indian Oil, we have 56,000 touch points, like customer retail outlets and other customer interfaces. So here, to manage to distribute the fuel to all those places, you need lot of real-time sensing and also real-time automation that is required. So companies are adapting this technology also at very rapid pace. So this is a schematic I wanted to show how this technology, big data technologies are helping working processes in protecting from process stochasticity, plant unexpected events, changing targets, market opportunities, and geopolitical events. So these are the few of the companies that are leveraging big data in process industries. Aspen Tech at Amrita, we have Aspen Tech software licensed for the academic use, and it will be of great help in your career. And there are other companies like Aveva, which is called Pro2, Yokogawa. Each company is providing services in different fields, and some there are some in overlap also. But if you see in the coming years to come, you will see a lot of big data foraying into the process industries. So coming to refining and petrochemical scenario, so the demand for petroleum products and petrochemicals continue to increase, although they predict peak oil demand around 2035. But crude oil demand would be driven by the petrochemicals increase. We'll see how petrochemicals is going to grow in the coming slides. So the major challenges in a refining and petrochemical scenario is the stringent emission norms and also efficiency, the gross refining margin. Gross refining margin is nothing but how much profit you are earning from by processing the crude and selling the products. And finally, refinery petrochemical integration. Stringent emission norms is nothing but you might have heard of Bharat Stage 2, Bharat Stage 3, and Bharat Stage 4. So, because of the upgradation in the fuel spec, both in terms of sulfur, octane, and other parameters, we'll have to upgrade our existing refining facilities. And so uh, it means an added cost to the company. So in that context, we'll have to improve the efficiency so that my overall processing cost is reduced. And refining petrochemical integration is nothing but there is a cut in the refinery. Cut is nothing but when you process crude, there are different cuts, and each cut is used for different purpose. Like one cut will be used for gasoline, one cut will be used for diesel, one cut for aviation fuel. Like that, there is a cut called naphtha. So this naphtha is the feedstock for petrochemical industries. So how to, because petrochemical, the profit from petrochemical products is very high. So how to maximize this naphtha while while supplying the current demand of fuels. So that is a big challenge. So this is a typical business process overview of a refinery. So basically we have crude oil receipt and crude oil storage, and then it comes to the refinery through pipelines or through pipelines majorly. And crude oil is received in ships to the crude oil storage facilities, and in refinery it is processed and it is stored in product storage, and then it goes for distribution. So it is a classification of how different divisions within in a refining company. So crude oil receipt and storage comes under pipelines, refinery and product storage comes under refining, and final distribution comes under marketing. So this is a typical uh, figure which shows how different cuts of crude oil and related end use products. So you have LPG, second is the petrol, that is the gasoline, and then you have the naphtha cut, which I was just talking about. And then you have aviation fuel, diesel, lubricating oil, fuel oil, bitumen. So it's not directly produced. There are a lot of primary, secondary, and tertiary processes, and a lot of streams coming from different processes are blended, and finally this petrol, naphtha, and kerosene is made, and other products are made. So this is a typical configuration of a refinery. So you have the primary units, that is the atmospheric distillation and vacuum distillation, and secondary units, that is to increase the yield. So basically what happens in crude, you have variety of cuts carbon molecules varying from C1 varying from C3 to up to C35, C50. So the heavier cut, to increase the yield of the distillates, that is the lighter cut, we use secondary processes, and then those tertiary processes to produce coke and other value added products. So basically, in a typical refinery, the configuration can be changed. Like the configuration is fixed, but the routing of the streams can be changed so that the overall profitability of the refinery can be increased. Let us say now the demand for gasoline is high, so obviously the price would be high. So we can maximize. We can change the streaming of the different cuts, and then my gasoline production can be maximized. So it's like simple if you look at the flow diagram, but very complex when you actually work out economics, lot of other technical feasibilities, etc. And coming to the petrochemicals, if you look at this diagram, if you look at this image, you can see a lot of day-to-day applications in terms of like home and office. You can see plastic pipes. You have PVC pipes at home. You have HDPE, LDPE, polypropylene, polyethylene, and toiletries, where you use polyethylene, high density polyethylene, and also in packaging. And in food and drinks, you have preservatives that are derived from petrochemicals. And if you look at transportation, you have tires, which is a polymer, other polymers. It is a product of petrochemical industry. And you have luggage, in which polypropylene high density polymers are used, and also in batteries. In even in fertilizers, you have this other ammonia and other hydrogen being used. So naphtha is also being used. So that is also a product of petrochemical industry. And you have textiles and electronics. So what not, you have wide variety of products that are produced from petrochemical industry. So just to have a sense of how petrochemical industry is going to grow, if you look at this is the GDP per capita on the x-axis. On the y-axis, you have per capita consumption of petroleum products. So if you look at India, it's very low. It's almost around 10 kgs per person. So, but if you look at developed countries, it's almost around 125, 130, and in some countries it is even touching 140. So you can see that it's increasing. The growth is huge. There is a lot of potential in petrochemical sector. So this is the typical value chain of petrochemical industry. So you have primary chemicals like light olefins, ethylene and propylene, and benzene, toluene, xylene, ammonia, and methanol, and these are being in turn converted into polymers, agrochemicals, and specialty chemicals. And finally, the end use products, that is the consumer goods, packaging, transportation, construction, agriculture, and pharmaceuticals. So I was talking about refinery and petrochemical integration. So there are many different layers of integration. So if you can see, if you have only refinery, that is at the base layer, and then you can include benzene, toluene, xylene extraction, and propylene unit, and then you have refining and stream cracker and paraxylene complex. So basically, you can I have mentioned that around 55% of the crude oil produced in 2050 will be used for petrochemicals production. So only 45% will go for your fuels like aviation fuel, other road transport fuels, etc. So basically, the demand for the fuel sector is decreased. So obviously, the technologies required for conversion of crude oil to chemicals, that is petrochemicals, will gain lot of importance. So now coming to the role of chemical engineering. So we have talked what is the energy industry and what all are the challenges and what all are the opportunities. So if you look at typical chemical engineering, this thing coursework, we have three fundamental subjects, that is thermodynamics. If you look at any process industries, some reactions are taking place. So how what is the maximum achievable yield for a given reaction. So that is defined by the thermodynamics, and we also study about kinetics, that is how fast the reaction will take place. So with what residence times you can achieve the conversion. And then transport phenomena, within transport phenomena you have heat transfer, mass transfer, and momentum transport. So all these three fundamental concepts put together, we will apply it in the process industries, and with the help of other fields like data science and other biology and other material science, economics, etc. And finally, they are useful in uh, designing and operating the uh, technologies. So this is a schematic. So what all are the inputs that are being fed to a chemical engineer? Yeah, the top three are the fundamentals that I have just discussed, and you have other interdisciplinary branches that are being interfaced with chemical engineering, and finally you have design engineering, plant operations, process optimization, etc. So the USP, that is the unique selling point of chemical engineering is that ability to think in terms of systems. So any like if you take any biological system or any natural cycle, so everything is taking place in terms of systems and interactions within these systems. So as a part of our coursework itself, we the it is designed in such a way that the mass transfer, momentum transfer, and heat transfer, the concepts we study, they allow us to think in terms of systems. And also another point is that we have knowledge of both mechanical and instrumentation. In mechanical we have strength of materials, thermodynamics, although there is little difference between chemical engineering thermodynamics and mechanical thermodynamics. And if you come to instrumentation, we have other courses like process dynamics and control. And if it comes to economics, we have process economics course. So we have knowledge of other departments also. So in a typical process industries, chemical engineer stands as a center of attraction, so that because he interacts with the different departments and try to solve the problems. And knowledge of math is also required, it's very much required, like numerical solutions, modeling, which is common for other branches. So because of this interaction with other fields, so it's called mutant phenotype, leading to interdisciplinary research. So better understanding of process and economics helpful in policy making. So this is a added advantage for chemical engineers. So if you look at the scope of chemical engineers, like in terms of employability, you have the manufacturing sector, you have services sector, you have R&D and academia, and then policy making. We'll see each one in detail. So Cheminge, see, you can think of anything and chemical engineering is involved in it. So oil and gas, paper and pulp, these are the few industries within manufacturing sector where chemical engineers are mostly employed. You have FMCG sector, fast moving consumer goods, where toothpaste, soaps, and other detergents, where chemical engineers are essential for running the plant operations, and petrochemicals, pharmaceuticals, etc., and also renewables. So within manufacturing, the scope for chemical engineer is like you have different departments where chemical engineers are required. One is the production, and another is technical services, and another is optimization, health, safety and environment, corporate planning. So if you look at production, basically they will this is where the production of the uh, oil, let us say chemicals, you have fuels, is taking place. So you will look after the whether my all parameters are okay, or whether to optimize any parameter. So technical services department, they help the production team in assisting in solving the problems, in analyzing the problems and finding innovative solutions. And optimization, so optimization, it's more of an overall function, because if you take a typical refinery, you take an example of Indian Oil, we have 10 refineries, and we will be procuring fruit from many parts around the world. So what happens in a typical optimization scenario, you will have to improve your profitability, and you also have to meet the demand. So for that purpose, we have typically around 76,000 variables within Indian Oil for optimizing, for feeding it into an IP model, which I talked during the big data. So in optimization, what happens? All these variables are linked to a program, and within that program an objective function is selected, and based on that objective function, whether it is to be maximized or minimized. So if I take a real time example, whether a particular crude has to be bought at this point or not, so that my profitability will be increased. So this is what optimization department does. And then coming to health, safety and environment, I told you about the emissions. So within refinery, we have lot of furnaces where lot of stack gases are emitted into the atmosphere, and you have lot of options of of fuels for burning your furnaces. And there are lot of what to say, technologies like zero liquid discharge. So all these aspects are being taken care by health, safety and environment. And finally, corporate planning. So the intrinsic character, the intrinsic skill of the chemical engineer to understand all the departments. So because we have touch with both instrumentation, mechanical, and other electrical, power and utilities. We are the interface for all of the departments, so that will help us in getting placed in positions like corporate planning. And coming to the services, uh, in services we have technology licensing one profile, and then we have engineering, procurement, and construction and process optimization. We'll see each one in detail. So technology licensing companies, we have, they provide technologies to different industries. Like if you see oil and gas industries, there are a lot of technology players like UOP, Halda Topsy, Shell. They provide technology. So for let us say for producing BTX, benzene toluene xylene, there are many technology players. So basically, they do R&D, they do their in-house R&D, and they develop technology, and they will try to scale up, and they will sell those technologies to these operating companies. Indian Oil is also a technology licensor. In the context of Make in India, they have developed a technology. R&D division has developed a technology called INDMAX, that is for fluid catalytic cracking, which is a part of refinery secondary process. So these technology companies work in close collaboration with R&D, and also they support operating companies like periodic reviews, how they can improve, whether catalyst can be changed, whether any revamp is required, like that. So engineering, procurement and construction companies, they design equipment for licensed technologies. So within licensed technologies itself, based on the customer needs, there may be lot of changes. There may be lot of constraints on the supply side. There may be lot of constraints on the product side. So based on that, they will have to design equipment, and also the process hydraulics, etc. And also they procure equipment and other services. So in the before making the plant ready for operation, the steps, that is the pre-commissioning and commissioning activities, are also involved. So these are the companies that are like comes under EPC companies. And coming to the process optimization, so I told about the big data. So one application is the advanced process control, and IP modeling and real-time optimization. So these are few companies. These are just an examples. There are many n number of companies providing these services. And policy making, like government bodies, like you have pollution control boards, you have for net zero emissions, you need to there is a system called carbon taxation, so carbon credits. So for all those things, the technical knowledge is required, and chemical engineers are best suited for that. And also in corporates, consultants in terms of strategic thinking, these are more of a managerial and technical roles, combination of managerial and technical roles. And also international agencies which do different studies, they also employ chemical engineers. So if you come to R&D and academia, there is a lot of scope in fundamental research. There is a lot of interdisciplinary research with respect to chemical engineering, that is mathematical modeling of biological systems and interface phenomena, etc. In terms of technology, the catalysis, smart materials, and novel processing methods. If you look at refinery, we have currently hydrogen based processes. So from hydrogen based processes to radiation based, ultrasonic based processes are being developed. So that is one example. And one example for this technology R&D is the point of care diagnostics. So it turns out that when you do blood sampling, the flow is not same that is in your pipes or something. So for that, the mixing and all needs different kind of setup. So for that, point of care diagnostics are being developed. And operations, like modeling of real time scenarios, like blending of crude oils, which is being applied in optimization. And there is a lot of interdisciplinary scope, that is nanotech in drug delivery, biotech in improvement of crop yields and all. So these are the opportunities, that is oil to chemicals, petrochemicals, artificial intelligence and machine learning in big data, and within healthcare you have pharmaceuticals, renewables, etc. So I would like to, I'm done with the presentation. I would like to take you through virtual tour of a typical process plant, uh, so that just to have feel for how process equipment look. So this is a typical distillation column. So the column here you can see, and we have other equipments like heat transfer equipment, like uh, air fin coolers, and also we have lot of reactors and control valves, lot of flow control equipment. So this is how a typical controller looks like. Most of may not be appreciating, will not be able to appreciate now, but just to show you how a typical process plant looks, I'm just sharing. And this is a typical heat exchanger, and we have fired heaters uh, that are used for increasing the process temperatures, and we have reactor. So this is the reactor. So that's it. So I'll finally conclude. So there is a lot of future is exciting for chemical engineers. And you have any questions, you can write to me. I'm sharing my contact details. Thank you.
Much, Gupta. Thank you for a very informative and a wonderful session. I'm sure that all the students loved the session. So before we end the session, I would like to ask one question like, how was your life at Amrita and what tips you would share with the upcoming students, just current engineering aspirants on choosing chemical engineering?
Yeah, life at Amrita has been wonderful. So, in a lot of aspects to it, like both technically and culturally, and how in terms of developing communication and how to there is a lot of exposure that I've gone through at Amrita. Coming to the facilities, you have facilities. I suggest all the aspirants, like batches, incoming students, to take advantage of it. and also good sports facilities, and also you have a lot of cultural activities. I think they will help you in overall development. And apart from that, we have there is special focus being given in terms of employability in the context of CAR, corporate and industry relations. uh, Only one thing I would like to say, after passing out from Amrita, when I compare to my peer group coming from other colleges, even colleges like IITs and NITs, most of my colleagues are from IITs and NITs. I see that you have a lot of facilities that are being provided at Amrita, and it is up to the students to leverage on those facilities. For example, it's specific to we have courses which courses on softwares, chemical engineering softwares like Aspen Plus, Aspen HYSYS, and also you have HTRI and other MATLAB. So learning these technologies at early undergraduate level itself will definitely will stand out when you come out of college. One more thing is there are a lot of research facilities are very you have very good research facilities. So many people will be confused by the end of their BTech whether to go for research or industry. So by the end of your third year or fourth year, if you are able to do good research and then publish papers, and then you will easily get to know whether to go for industry or R&D, whether you will easily able to test your personality, and decision making will be very easy. So I suggest everyone to like take maximum out of Amrita, and I can confidently say there will be a lot of opportunities waiting for you.
Thank you so much for sharing your experience, and once again, thank you for a wonderful session. So, thank you, students, for watching us, and that's all we have for you today. We'll see you
Thank
all
you.
for day 6 of Great Amrita Alumni Conclave, which will be happening tomorrow. The session will start from 10:30 a.m. Okay, so we'll see you all at that time. Thank you so much.